Students, really, I am very happy to invite all of you to this wonderful discussion on on Unit 5. Okay, so in the Unit 5, the first definition is this: a square integrable or square integrable function. What is a square integrable function? Let f of x be a function. F of x be a function. Suppose you are taking this absolute value of this, and then you are taking an integration from a to b dx. If this total value is less than infinity, then this function is called square integrable. I repeat again, let f of x be a function. Take the absolute value, square it, then take the integration from a to b dx. Its value must be less than infinity. Then f of x is called square integrable function. Square integrable function. Now, what in I2 function? I2 function. Let f of x is a square integrable function, SIF, square integrable function. And if this f of x satisfies these three conditions, if this f of x satisfies these three conditions, okay, the first condition is integrable a to b, integration a to b, and k of x comma t, kernel of this particular function, k of x comma t is absolute value is less than infinity. I mean double integration dx dt. Here dt should come here, it is lost somewhere. Okay, so it is better to write here dt. Dt should come here. Okay, very interesting, am I correct? Dt. If f of x is a function, k of x comma t is a kernel of this function, and that this double integration a to b dx and a to b dt is less than infinity when x comma t belongs to the closed interval a comma b, then we say that this particular function is I2 function. So I repeat, let f of x is a function. For that, the kernel you are squaring, taking double integration over dx dt, and if that value is less than infinity, for all x comma t belongs to the closed interval a comma b, and second condition, integration a to b, the kernel of x comma t, the absolute value square dx must be less than infinity for all x belongs to a comma b, and as well as the integration a to b, k of x comma t square dx is less than infinity for all x t belongs to a comma b, then we say that this particular function is called I2 function. So it has to satisfy these three conditions. Now, what is an inner product? Suppose f and g are two complex I2 function. We defined just now what is I2 function. It has to satisfy all these things. So f and g, okay, are two, f and g are two f and g are two I2 function which is of complex in nature, then the inner product is written like this and defined like this. Okay, written like this, f dot g inside the bracket, and is exactly equal to f of x. G of x is a complex conjugate of g of x. Complex conjugate of g of x called g dash of x. So you are finding the product of f of x and a conjugate of g of x, and then you take integration from a to b dx with respect to x. and this operation we call it as inner product here as far as mathematical method is concerned. Okay, so f and g are two complex I2 function, and f dot g, that is the inner product, is defined as a to b f of x g bar of x dx. That is, you are taking f of x, finding product with the g bar of x, then you take integration a to b. This particular operation we call it as inner product. Okay, now let us take the what are they behind the screen? Yeah, orthogonality of I2 function. Suppose f and g are two functions, as we have just explained. F and g are two complex I2 function we explained just before. Suppose their inner product equals 0. Its inner products equals 0. That is, by definition, integration a to b f of x, the conjugate of g of x, and that integration value equals 0, then f and g are called orthogonal complex I2 function, orthogonal complex I2 functions. Okay, just its inner product must be equal to 0. You are taking f of x and conjugate of g of x, finding the product, take the integration over a to b, and that value is 0. Then we say that f and g are orthogonal to one another. Now only one last definition is this norm of a function, what we call norm of a function. Okay, now look at that. Norm of a function. Norm of a function is defined like this. Suppose f of x is a function. Okay, f of x is a function. Now we are taking the norm notation like this, and it's nothing but the inner product of f of x and its conjugate, then add integration from a to b dx and take the square root of that, and that value is called the norm of a function f of x. So norm of a function f of x is nothing but you are finding the product of a function and its conjugate, then you take integration from a to b dx, take the square root. Otherwise we can say that this f of x and the conjugate of f of x we are writing as absolute value of f of x the whole square. For that you are taking the square root, and that is called norm of function. Okay, so in this particular class what we have studied is nothing but what is a square function, square integrable function, what is an I2 function, it has to satisfy three conditions. Next, inner product, okay, is defined like this: integration of f of x to g bar of x, where f and g are two functions called a integral inner product. And then this is orthogonal. When we say that orthogonal, if the inner product equals 0, it is called orthogonal. And last one, norm of a function. Norm of function is defined like this. Okay, so that is, we are taking integration of f of x f bar of x dx, that square root you take, that's called norm of a function. So with that we are coming to the end of this session. The next session we will be studying other concept in this topic. Thank you.